Hey everybody. Today we have a big day. This is a huge topic for us. I don't think it's a difficult topic, so I don't want to mislead anybody. But in terms of the importance of today's topic, I cannot think of a bigger one for your current status as well as future math courses that you're going to attempt. So I want to jump in on today and us start to discuss solving quadratic equations. Okay, here we go. In order to get warmed up, I think we need to tackle a couple problems. So that instruction that you see at the top of your screen is going to be our instruction for the entire day. I want you to solve some equations. And if all I state is solve, then I want your exact value. So I'm going to leave those three equations up on the screen, and I want you to go through and try to solve each one of them. Okay? I want you to pause the video. I want you to get a full solution for each, and then we'll see how we match up. Okay? Pause the video now. Okay, we're back. So what I want to do is I want to quickly go through each one of those equations. So you'll see those three equations up right now. I should be pretty comfortable to kind of fly through these solutions, I hope. So first equation, that was your warm-up. Like you see some brackets, you see some X's on both sides. This line, I would strongly suggest, that is, simplify each line before you start thinking about isolating variables. I can isolate by putting my X's on the one side. That means my constants on the other. If you wrote down that, then I think we're doing okay, but I'm really hoping we skipped that line and you went straight to a 3. Okay. If you have that orange solution on your page, good. You are quite comfortable to solve a grade 9 equation. Okay, there is us solving a linear equation by isolating. Okay, I want to take a look at B. B, I take a look and I notice I've got two a squared terms. There's my variable terms. So for me to go through then, I'm going to try to put those on the same side. So there would be my 9a squared. That means I want to get rid of that. There's my 81. I should be quite comfortable then to divide out that 9. And now when I take the square root of both sides, we should be able to quickly get to plus or minus 3. There's a little bit of review from last time, us going through and solving an equation by isolating. Good. If we've got that green, then I would argue we're doing pretty well at solving a grade 10 equation, even though you should have seen B in grade 9. Now what I want you to take a look at is problem C. When we zero in on problem C, you'll notice I have an x squared term, and then when I collect my single x terms, I get that. I may be tempted to do that, but that's not going to help me at all because I cannot collect those two x terms, those two variable terms, into one variable term. That's what I need to be able to do to be able to isolate. Or at least I need to be able to do that easily, and I can't. So the equation in C, that's the doozy. That's the one that's stumping us, and that's where we're going to go with today. So if I can get you to look at that entire screen, the screen in its entirety, I'm hoping we were automatic on A, and now after our last topic, I hope we are automatic on B, and if we were stumped on C, no problem, we should have been. I want to jump in and I want to talk a little theory, and this is where we're going to make the next leap in the equations we can solve. You see a statement that I put up on the screen. When a product is equal to 0, what must be true of its factors? So there is a statement I made that really ends in a question. When a product is equal to 0, what must be true of its factors? So if you were a little unsure what I was talking about when I said a product equal to 0, take a look at the goal down below. There is a product equal to 0. Product means multiply. Product is the answer we get when we multiply. And therefore, the answer we get when we multiply is 0. So that's what I've got there. AB equals 0. A times B equals 0. The question asks, what must be true of its factors? And really what I'm going to do is I'm going to zero in on that AB statement. I'm hoping that we would be quite comfortable that if you saw A times B equals 0, that is something times something equals 0, that we would then say, well, the first thing has to equal 0, or, notice it's an or, my second thing has to equal 0. The only way that I get two things to multiply together to give me 0 is if one of those things were 0. So you can see that in that pink conclusion statement. Therefore, A's got to equal 0 or B's got to equal 0. Maybe they both equal 0. I don't know. But I know at least one of them does. That piece of theory you see on your screen is going to be one of the most important pieces of theory that you're going to use to be able to solve quadratic equations. If I can get a product equal to 0, then I know one of its factors has to equal 0. Let me examine those factors. Okay, we are going to use that property that you see on the screen over and over and over again. I do not think that I am lowballing or exaggerating this by any means if I was to say you're going to use that 1,000 times over the next couple years. Okay, I want to get some practice using that theory now so we can see why it's so useful. Let's jump in and tackle a couple other problems first. I want you to take a look at the screen that I have in front of you now, and I've put two new equations, equation D and equation E. You'll notice that each of those equations, the expression has been factored, or it's written in factored form. I want you to zero in on D. D says this x times this whole thing, because we got the brackets, this whole thing, x plus 4, has to equal 0. So I'm hoping you can see that's your A times B equals 0. Something times something equals 0. Can I get you to look at E now? You'll notice the same thing. Because of the brackets, this whole thing, 2x minus 1, and because of the brackets, this whole thing, 3x plus 5, when multiplied together, give you 0. There's that property again, a product equal to 0. Okay, let's jump back to D, and I want your focus to be on D. The concluding statement I can make if I look at D, because I see x times x plus 4 equals 0, I know that one of those factors has to equal 0. I could then say, therefore, the first factor equals 0, or the second factor equals 0. Look again up at your original equation. Something times something equals 0. Now look at my pink. Therefore, one of those somethings has to equal 0. Look at what you just built in pink. And you'll notice those are really easy statements or equations. The first pink one is already solved. I know x has to equal 0. Or look at your second pink equation. That is the easiest of easy equations to isolate. Look at what we just did. We just solved that equation. Okay, jump over to E. You now have something times something equals 0. So we have a product equal to 0, and we know, therefore, the first thing has to equal 0, or the second thing has to equal 0. Well, if that's the case, yeah, they're not the easiest of easy linear equations, but they're pretty darn easy. Now I'm hoping that we can see, get rid of your 1, divide out your 2. Same thing on the other equation. Get rid of your positive 5, divide out your 3. And you've come up with your 2 solutions. Okay, we just solved quadratic equations where we couldn't isolate. Now, if you're looking at both of those and you're saying, yeah, but those don't look like equations we dealt with, I'm going to argue to you, no, they don't. However, if I can get you to look back at equation 1, I want you guys to see something. That if I actually took the equation in the original and I expanded my brackets, I would get that orange equation. And notice we have a situation like what we had before. Look at your two orange terms. Can you collect your variable terms into one term? No. This would have been an equation where we would have had problems solving that before because we can't isolate easily. But notice, you had no problem solving the equation above when it was factored. Take a look at E. If I was to expand the brackets up in E, I would get 6x squared. I get a plus 10 minus 3, so there's a plus 7x, and a minus 5. Well, this would have become the problem that we finished off with in C, where we put our variables on one side, our constant on the other, and now we're trying to figure out how do you collect your two variable terms into one term, and you can't. We couldn't solve it. But again, look back up in the original, we had no problem when it was factored. So what you've come across in D and E is the strategy we're going to use most often to solve quadratic equations when you cannot collect your variables into one variable term. If we can factor it, then we can solve. This is why I've been harping on you guys so much as to your importance of the ability to factor trinomials and factor polynomials. This becomes the main way we solve equations. Okay, there was some huge theory that we just had on the screen there for D and E. What I want to do is I want to jump into some stuff that's going to look maybe a little more usual, something we're going to encounter an awful lot. Okay, here we go. So you see two equations up on your screen right now. I don't even want you to look at G. Let's not focus on G. Let's go ahead and focus on F for right now. If that was an equation that you were walking into out of grade 9, then you would look at that equation and you would say, well, I want to get my x's on one side of the equal sign and I get my constant on the other. I want to isolate. However, we notice you cannot collect your two variables into one variable term. That idea of us trying to isolate doesn't work easily. So we have a different method. Look at the right side of your equal sign, and you notice it's equals 0. We like having one side of our equation being equals 0 because if we can get the other side to be something times something else, then if it equals 0, we know we've got a situation where we can examine the factors. One of the factors must equal 0. So what we can do then is take that left side and try to write it in a more useful form. That is, let's try to factor. So you take a peek at the equation in F, and it's a simple trinomial, nice one to factor. Two numbers that multiply to give 77 and add to give 4. That one's not too bad. How about a negative 11 and a positive 7? So you can now see your left side is factored. Okay, why was that useful? You now have something times something gives you 0. So what does that tell you? Well, then that tells you, therefore, the first thing has to equal 0, or the second thing has to equal 0. And really, I should stop saying thing, but I should say factor. Okay, look at what we just built in pink. There's your easiest of easy equations. You can now isolate and come up with your two solutions. Look at that. Nice. Okay, I am so confident in those, I'm not even going to check. But of course, you could obviously check. You could sub an x equals 11 back into your original, see if that equals 0, and then sub an x equals -7 back in, see if that equals 0. We should be good. Beautiful. Okay, we now have a way to solve our equations when we cannot collect our variables into one variable term. Okay, now I want your focus to be on G. How can we tackle this so we make it so automatic for us we could almost shut our brains off? The first thing I want you to focus in on, can you collect your variables into one variable term? No, we can't. But when we look at the other side of the equal sign, we notice it's not a 0. I really like it when it's 0. Now, I want to walk through something really quick just so we understand why it's so important to have 0. Okay, I'm going to get rid of everything that I just underlined. Let's imagine that we forgot about the equals 0 part and we focused on the factor part. Well, then what I'm going to do is I'm going to try to factor the left side. Hey, the first thing I always look for when I factor is a common factor, and I notice that there is a common factor of a in both of those terms. Okay. Well, look at what you have on the left side now. You have something times something else, but it equals 15. Now, you may end up looking at that and going, that's no problem. 3 times 5 equals 15. I know something times something that equals 15. And so maybe it's a 3 times 5 equals 15. That's what you're thinking about. Well, then that means that my first thing, a, has to equal 3. And my second thing, a minus 2, has to equal 5. And look, you could solve both of those. Nice. A equals 3, a equals 7. Well, if you do a check and you sub back in there, so if I check and I sub in, I don't know, let's try the a equals 7 one. Well, then 7 squared is 49 minus 2 times 7 is 14. Wait a second, that's 35. That does not equal 50. Wait a second, what went wrong? Well, maybe if we want to examine something just from the possibilities, can we play through a couple things? Notice how I just said, well, maybe the first thing was 3 and the second thing was 5, because that's 3 times 5 is 15. Well, what if the first thing was 5 and the second thing was 3? I would get different solutions. Well, what if the first thing was 15 and the second thing was 1? That's 2 things that multiply to give 50. Well, then the other thing could be 1 and 15. Okay, here's where it really gets ugly. What if the first thing was 7? And you might be looking at that going, yeah, but wait a second. 7 doesn't multiply by anything to give me 15. And I'm like, sure it does. 15 sevenths. Notice if you multiply those 2 things together, you get 15. It doesn't even have to be a factor of the first thing. That could be like 11 times 15. Well, then it would be 11 times 15 11ths. Maybe you're starting to see that there are infinitely many values that could come together to multiply to give something else. Shoot, that right side being 0 is super important. So let me get rid of all of that mess. And this is me just getting rid of prioritizing factoring over equals 0. So what do we want to do then? What we want to do is we want to take a peek and say, can I collect my variables into one variable term? No. Is my right side 0? No. So what I need to prioritize then is making that right side be 0. So my first line is going to be getting all of my terms on one side of the equal sign. By doing that, I just cured my problem on the right. Look, I've got an equals 0. And if that's an equals 0, now I can look to factor. Okay, two numbers to multiply to give 5 and add to give -2. That would be multiply to give 15 and add to give -2. That would be a -5 and a +3. Now that I have those factors multiplied together, those factors equal to 0, therefore, the first one has to equal 0, or the second one has to equal 0. And now when I solve those equations, I get my first answer, 5, or my second solution, -3. Nice. We're solving quadratic equations by factoring. Okay, I want to talk to you guys about some process and a line that you can skip moving forward. I think as you get more and more comfortable solving these equations, we're going to start to skip the line I just crossed out, and we will jump straight to our final solutions. We may not be there yet. Worst case is you put in the line I just scribbled out. But if you start to feel comfortable doing it, I want to jump that step. Okay, let's keep going with some quadratic equations. Let's take a look at h and I. I want everyone's focus to be on h. The first thing you look at, can you collect your variables into one variable term? No. So what do? We move everything to one side of the equal sign. Now that we have the right side equal to 0, then we want to try to factor it. We take a look on the left side. We are able to factor that pretty quickly. Two numbers that multiply to give 25 and add to give -10 are -5 and -5. Now, if you write down the green, that's okay, but I would love it if instead we wrote down the gold. That gold is better. If I have two of the same factor, I should write it as a square. And now that we have that instance, we'll notice, therefore, something squared gives me 0, well then it must equal 0. And therefore, m equals 5. Nice. Okay, I want you to take a look at the line that I just wrote down. Or the full solution, I should say. And if you were to give me just the gold lines, you have a perfect solution. Now, why do we really like to write down the gold? It's proper form. But you'll also notice that by me not writing the green, then I skip ever writing down this line, which is, therefore, m equals 5 or 5. Like, we don't need to see that. I'm not going to state that the possible solution for an equation is the same twice, that m is 5 twice. No, if 5 is a solution to that equation, then I just state it once. Okay, I think we are at a point where you guys are good to be able to solve equations yourself. If you want to, try to skip over the pink line. But your job when you tackle your next couple problems, be correct. Job 1, be correct. Job 2, be quick. So I'm just going to put a little wavy line down here, and I want you to give question I a shot. You see the equation in I want you to give it a shot and see if you can solve that equation on your own. Okay, pause the video now. Okay, we're back. So I am hoping you took a peek and you saw you had a square D term and you had a single D term and they cannot collect. So you put everything on one side of the equal sign. Now, why did I want to tackle I? Some of you may have been, inclined to go through and say, yeah, but like, why would I make the gold equation when I could have just brought my D squared term over to the right? Rather than get rid of two terms, I could just got rid of one, and that would have been faster. Up above the problem, I'm just going to go ahead and write, that would have given me this equation. And I just want you to notice that is 100% correct. But if your next action is to factor, I would almost guarantee you are way better to factor a positive leading term, an expression with that, versus an expression with a negative leading term. So if I can add in a little bit of motivation to you, when you're trying to decide what side of the equal sign to get every term on, try to get a positive leading coefficient. It's going to make your factoring a lot easier. Okay, I'm going to get rid of that pink and green up top, and I want to jump in and solve that equation in D, or in I, the equation with D's. Okay, I get to that point, now I'm trying to factor. So this becomes a complex factoring. I've got a leading coefficient of 2. Here's why it's so important for us to be able to factor. 2 numbers will multiply to give 2. 2 numbers will multiply to give 6. I am trying to get my 7. Let's say that I started that by going 2 and 3. As a little review for us, if I went to multiply that across now, I'm going to get a 6 and a 2. There's no way I can get a 7 out of that. Also, you'll notice, if I put those terms there, I would have a factor with a 2 and a 2 in it. That would be a factor with a common factor, and I notice I have no common factor in my equation. So I know that I could skip over that as an option, and instead, let me write the whole thing out, go straight to, it must be the 3 and 2, if those were the numbers I chose. I do a quick multiply across, and I notice I get a 4 and a 3. I can get 7 out of that. I want a positive 7, so I need a plus between both of those terms. I can now factor it into a 2D plus 3 and a 1D plus 2. And here's where we're going to try our best to skip a line. If I skip over that line and I go straight to my solutions, then I'm going to say, therefore, D equals, okay, from the first factor, maybe we can see getting rid of the 3, so we're going to change the sign on it, and divide out the 2. That's going to get me a D value of negative 3 halves. See, I can skip that line. Okay, if we did not get that value, then I'm going to put in that line. Therefore, my first factor equals 0. Now maybe you can see with a little extra focus where the negative 3 halves comes from. Get rid of the 3, divide out the 2. Nice. Okay, I think the other one was the easier one to come by, and you could have said D equals negative 2. If you gave me the gold with the green, perfect, perfect. I think I even misspoke earlier and said I only needed, oh, no, we're good. If we struggled to get the negative 2 solution, then we would be putting an or, D plus 2 equals 0, and now getting rid of the 2. Okay, if you gave me a gold and green solution on I, then I think you have a great solution. Outstanding. If you included the pink, no problem. You're still doing great. That would be the first quadratic equation that you've solved by yourself with factoring. Outstanding. Okay, I want to talk about a problem now that's going to lead you into a common mistake situation. Okay, I want us to address something to make sure that we can kind of rule it out before we ever get into the habit of it. Okay, let's take a look at it right now. I want you to take a look at the equation in J and kind of focus in on the left side. The left side, the equation being in white. I've put a versus with the one in gold on the right corner because I want to kind of examine both. So let's look at the left, x squared equals 6x versus the gold. So let's forget about the gold for a second. When you take a look at the equation in white, one of the common strategies that you can do is to say, yeah, but I'm going to like divide out and shrink stuff down. We call that dividing out common factors. Well, if you take a look at the equation in white, then maybe you notice there's an x on both sides of the equal sign. And you learned back in grade 9 that as long as you do the same operation to both sides, your equation stays balanced. That's very true. So maybe you look at having an x on both sides and say, yeah, but if I divide both sides by x, I can shrink down my equation. I'm doing the same thing to both sides. So what you're going to do then is divide the left side by x and the right side by x. Well, if I divide out an x from the left side, then that gives me just an x. And if I divide 6x by x, that leaves me with 6. Look how fast that was for me to solve. X equals 6. I'm hoping we can see that, yes, while x does equal 6, look, sub back in and x equals 6. Your left side is 6 squared. Your right side is 6 times 6. X does equal 6 to make that equation true. But there was a solution that disappeared. If you take a look at my blue solution and now compare it back to the beginning, notice if I subbed in x equals 0, well, 0 squared is 0, and 6 times 0 is 0. I would have my left side equaling my right side. What about my x equals 0 solution? It disappeared. And that's what I want to focus in on. That's why it is so important to listen to the wording that I'm using when we solve our equations. If you cannot collect your x's into one variable term, then get everything to one side and look to factor. Notice now if we zero in on the gold. If I follow that advice, I can't collect my x's into one variable term, so I move everything to one side. Now I look to factor. Well, if I factor, then I can pull out a common factor of x and look at what I just created, a product equal to 0. Well, I know that therefore my first factor equals 0 or my second factor equals 0. And if I put that old line back in, now you see you get your x equals 6 solution that we had before, but you don't lose your x equals 0 solution. Okay, there is nothing wrong with trying to simplify an equation by dividing out. In fact, that's going to be the advice that I give you shortly. Always shrink down that equation whenever you can. But never, ever, ever divide out your variable. Ever. You can see it in pink on the screen that whenever you divide out your variable, you are dividing out a solution. Okay, now that I've addressed that from the get-go, nobody's going to make that mistake. And now we get a chance to gain some extra experience. Okay, I want us to go through and solve as many quadratic equations as we can. Okay, I want you to start building up some instinct now. We now understand how to build it, how to solve an equation. Now let's start to build up some of the quirky stuff. How do we address some of the weird things? I don't even want to call them weird. Some of the situations that may arise. Okay, I want you to try K. Okay, I want you to copy down the equation in K, and then I want you to try to solve that equation. Okay, pause the video now. Okay, we're back. So, in tackling question K, you may have chosen, since all your terms are on one side of the equal sign and you cannot collect your variables into one variable term, you may have tried to factor that equation as written. However, because of a negative leading coefficient, you may have found it was a little more difficult than what you wanted. My advice to you, do not deal with the negative coefficient. Just don't. Now, some of you may have chosen and would have said, yeah, but I'm just going to think about everything going on the other side of the equal sign. In fact, you may have written it that way, and your solution may have looked like this. And that is great. Great. I think your focus, once you determine that you cannot collect your variables into one variable term, your focus should be put your terms on the side that's going to give you a positive leading coefficient. So maybe we did that. Maybe we also addressed something that we just spoke about. If you don't like the fact that that leading term is a negative, then get rid of it. Change the sign of it. Now, you can view changing the sign of it as multiplying by -1, or you can choose dividing it by -1. Whatever you like. But as long as I remember that if I'm going to do one of those operations to one term, I have to do it to all terms, then maybe you came up with this equation of x squared positive 10x positive 16. Notice all the signs changed. And then 0 times or divided by anything. There's my 0. I'm hoping that we took one of those two actions, the green or the blue, to create your expression, your equation, all on one side of your equal sign. Now we can finish it off. Regardless of which one of those we have, we should be looking at the fact that two numbers that multiply to give 16 and add to give 10 are 8 and 2. I'm hoping we can now skip the next line, which would be therefore x plus 8 equals 0. So therefore we get x equals -8. Or x plus 2 equals 0, which would give us -2. Okay, hopefully I have one of the green or the blue beginnings and then the pink to finish it off. If you do, well done. If we don't, we just learned something new, and now that becomes a strategy we can use. Okay, I want you to do the same thing on L. I want you to copy down L, pause the video, and then we'll come back in the end and see how we match up. Okay, pause it now. Okay, we're back. I think it should have been almost a unanimous decision that everybody should have had this equation at the very beginning. You recognize you can't put your variables together into one variable term, so you get everything to one side. Everybody should have been thinking about that on the left because of a positive leading coefficient. And now we're looking to factor. Okay, one of the instances that is going to get in our way is going to be the size of the numbers we have to work with. Like, you start to look at it now and you go like, okay, two numbers will multiply to give 10. I don't know if I'm doing two numbers will multiply to give 6. Like, you're starting to go through it. The numbers starting to get a little bigger. You're trying to things. There's a 10 and a 6. That doesn't get me 32. You flip some stuff. You try to see how that goes. If I can add something to your strategy, take a look at all three terms. And do you notice that each term, 10, 32, and 6, all have a common factor of 2? So if I recognize that I have a common factor in all three terms, then what I want to do is I want to divide out that common factor. Look at the right side. That is equals 0. That means I can divide out my common factor. I don't have to just factor it out. The other item to be conscious of, because I'm dividing out a constant, I'm not dividing out a variable, then I know I'm not losing a solution. So watch what happens if I divide both sides of my equation by 2. I get two things that really happen. I just got rid of a common factor of 2 expression. And secondly, now I get smaller numbers to work with. I like having smaller numbers. It's going to make my factoring easier. Especially, look, now I've got prime numbers I can work with. So when I go through to factor that now and I say, well, two numbers that multiply to give 5 and two numbers that multiply to give 3, I can pretty quickly come in on those as my options, trying to get to my negative 16 in the middle. So I can factor it pretty quickly into a 5x minus 1 and an x minus 3. We might be a little hesitant towards jumping to that final line. I want you to really practice it. So from my first factor, I have to get rid of the 1, divide out the 5. Or from the second factor, get rid of the 3. I'm going to put the pink line in for the last time that maybe what you had was 5x minus 1 equals 0, or x minus 3 equals 0. And now we can see the get rid of the 1, divide out the 5. Okay, if you have that solution to L, I think you are doing great. I think L's got a lot of the stuff that we want to talk about. And if you combine it with K, with the idea of negative coefficients, on leading coefficients, then I think you've got everything that you're going to use in solving quadratic equations by factoring. So what I want to make sure we do is we just get that process down on our page. I want us to have something to look back on so we can reference it quickly in terms of key strategy. Here we go. Make sure you get that down on your page. There is the whole key to being able to solve these types of quadratic equations quickly. When you cannot collect the variables to one term, then we want to factor and solve each factor equal to 0. When you cannot collect the variables to one term, then get everything on one side of the equal sign. Factor it and solve each factor equal to 0. There's your strategy. And that should be the dominant thing that we try. Okay, I want to leave you with one more problem. That's it. And then I think it's time for you to practice. Okay, here we go. There's your question M. And there's the last one for today. I want you to go ahead and try to solve M. Okay, we're going to pause the video, come back and check. Pause it now. Okay, we're back. So I just wanted to throw out question M at you because that is a problem that we solved last time. And I'm hoping that you haven't forgotten everything you did before. So I would love to see on your page this solution. Hey, wait a second. I can isolate my variable. Hopefully we jump straight to the green. But now to get rid of the squared, I have to take the square root. And I remember when I take the square root, I get two possible answers. For me to take the square root of my 1/16, I have to take the square root of the top and the square root of the bottom, of which I would love it if you gave me just the green of plus or minus 1/4. If you gave me the green, outstanding, that is a super efficient solution. The blue is all the middle steps to get there. I think that I would have had very few of you do that. And it's just because of what we've been doing all day. That I would have had some people that would have said, oh, but wait a second. I thought we were factoring. And I'm going to say, no problem. If you take a look at the original equation, 16x squared minus 1 equals 0, and you say to yourself, hey, can I factor that equation? I hope we recognize that's a difference of squares. So if I just copied that equation back out over here again, then I could factor that expression into a 4x plus 1 times a 4x minus 1. My difference of squares is going to factor into conjugates. Same terms in each one, different signs in between. The line that we should now be skipping is going to be the therefore, and I'm going to even like jump a line. Like if you want to put this line in, how about we at least jump to this? 4x has got to equal -1, as opposed to just the 4x plus 1 equals 0. Or 4x has got to equal 1. Like jump to that. You then come in on therefore x equals -1/4 or +1/4, of which the best way to write that would be your plus or minus 1/4. Notice that by factoring, it can help us a little bit. Okay, I would hope everybody gave me the first solution. I would hope. But a super common mistake is to forget about the plus minus. A super common mistake is to just take the square root and you go, hey, square root of 1/16, 1/4. And then afterwards when we talk, hey, plus minus, you're like, shoot, plus minus, I always forget that. Well, if you take a look at your factoring solution, you're not going to forget the plus or minus. It doesn't really cost you a whole lot more in terms of time. The first solution is better. It's better. But if you are somebody that notices when you were isolating that you kept forgetting the plus or minus, maybe factoring becomes the strategy you want to use. Okay, that's it for today, and I think we've had a great first day on solving quadratic equations by factoring. Like I said at the very beginning of today's lesson, this was such a huge topic for us, and it really swings the door open to us to the types of equations that we are able to solve. Your job right now, you really want to get this topic to the point where you hardly have to think about it. You hardly have to think about it. That you can almost just put it into auto, like seriously, put the cruise control on, and just go through and be able to factor and solve quickly. Okay, the only way we can do that is to get a bunch of practice. Your practice is so important today. Okay, jump in. Best of luck.